So I'm here today with my good friend Colin Higgins. Colin has been drilling manager for a number of companies operating in the North Sea. And in fact, one of your last projects, you were actually looking at the drilling planning for the Cambo development.
Exactly. Thanks, Mike. It's lovely to be here. And hopefully we can make some interesting conversation for everyone today.
I'm sure we will. And of course, you're our man in Oz, but you're over in the UK right now.
In the UK for the rest of the summer, back in Australia at the end of August.
Great stuff. So we'll be hearing more from Colin down under in future episodes, I hope. So today we're going to look at the drilling rigs and also the costs that there have been in exploration to date in Namibia. So here's a map of Namibia, as you can see, and if we start looking at the blocks offshore, this is a map that we keep up to date for all our TROVE subscribers, and it's very clear, shows where all the operators are and all the active licenses. As well as that, in pink you can see all the blocks that we understand are under negotiation with the regulator. Now, many of these blocks have been under negotiation for quite some months, but if there are any updates, you'd be sure you'll find them here back on our channel. So currently there are 2 rigs operating in Namibia, and they are down in the south in the Orange Basin, and the Tungsten Explorer is working for TotalEnergies and the Deepsea Bollsta is working for Shell. In terms of why do you choose what sort of rig for Namibia?
It's mostly driven by water depth and met-ocean conditions. The most important thing, I suppose, to note here is the water drilling depths that we're drilling in. That's between 1,500 and up to 3,000 meters of water. So that's our primary concern. Leaves us with drill ships and harsh environment DP semi-submersibles.
Okay, and about the target depths, what can these rigs what depths can they reach?
The rigs will drill to at least 35,000 feet, so well depths of 6,000 meters are the sort of things that we're looking at in Namibia, are well within the depth capability.
Okay. Now, why do you choose a drill ship, and when do you choose a semi-submersible rig?
Drill ships tend to be used earlier in the exploration phase when we don't have much in the way of shore-based facilities, and you might have a very high variable deck load, so you can carry everything you need. Like a snail, I guess, carries its house on its back. You can take everything that you need. With a drill ship, semi-subs require resupply.
Okay. And I've never seen a rig or a ship that looks like a snail, but that's an interesting little scenario there. And then one of the other major considerations for choice of rigs?
Cost, of course. We always look at, we want the best rig at the best price. We're looking at a very small subset of the rig market here. This is the rigs that have been operating in Namibia recently, amongst the top 15 rigs in the world in terms of their water depth and drilling automation and drilling systems.
Okay. And so is this kind of becoming one of the areas where all these rigs are kind of getting drawn to?
It certainly is, and it's very much the rigs that were designed really to work in the high latitudes of Norway and UKCS and North Atlantic margin. These are the rigs that are now moving and becoming the favoured rigs for working in offshore Namibia. So it's quite a big sea change, let's say. Yeah, it's interesting to see that these mobile offshore drilling units are designed to work anywhere in the world, and some of them have been effectively inappropriately named, and a good example is the Stena Icemax. So although it was built in South Korea 2012, its first work was actually South Atlantic, subsequently in Canada, and then across to the west of Ireland, and then into the Mediterranean to the Eastern Mediterranean campaign, and then back to Ireland, subsequently in the Caribbean and Mexico, and then across to Africa, back to the Eastern Mediterranean, and then down to Gabon. And then finally, it's about to drill in Canada, offshore Newfoundland, where it may eventually see some actual ice.
So the Icemax will eventually get to see some ice, okay? And after that?
Back to the Gulf of Mexico.
So no more ice when it gets there.
So these are really, we talk about mobile offshore drilling units, these are very mobile. The first rig that we're going to look at in a bit more detail is the Tungsten Explorer, currently contracted to Total It's the rig that actually drilled the Zeus 1 gas discovery in the Cyprus block in December 2022. And it will go on now and drill the Venus 1A well and test the Nara 1X, formerly, well, sometimes known as West Venus. And currently it's in a water depth of 2,000 meters. And the second rig we can look at is the Deepsea Bollsta. Again, it was a rig that is currently drilling in the water depth of 2,210 meters. And the TD is over 6,000 meters. And it's the rig that discovered the Jonker 1X. Interestingly, now we understand that the rig has had its contract extended for a further 6 months by Shell. It was built based on a 5-year contract with Chevron to develop the Rosebank field west of Shetland, North Atlantic. So it's a very high spec package. So originally it was built on behalf of Dolphin, and then it passed to Seadrill, and it's currently under the management of Odfjell.
Well, really kind of one that got the ball rolling with, this was the well that discovered Shell's Graff discovery, the first announced discovery. It was the Ensco DS-10.
Yes, again, a modern dual derrick drill ship, and it was owned by Valaris. Another drill ship, the Maersk Voyager, was the rig that discovered the Venus discovery in a water depth of around 3,000 meters and had a TD again over 6,000 meters. It's left the region currently in the Gulf of Mexico.
So another rig, it looks huge, this one. This was Island Drilling's rig, the Innovator, thank you. And this was the well that was used on the Gazania well, which turned out to be a dry hole in the Orange Basin. But, I mean, that rig looks absolutely enormous.
It does, but it's not. It's one of the smaller of the DP semi-subs in the market. So there's a rig that's worked quite a bit in Norway and in the Barents Sea, but it's a relatively small rig. It's not amongst those very high spec biggest rigs in the world list. Okay, and that kind of makes sense because the location is actually quite close to shore, so it was in much shallower water than some of the bigger units that we've been talking about. Other rigs that we understand are earmarked for Namibia, the Deepsea Mira. The Mira, again, it was built as a Seadrill rig, and it was the sister rig, essentially, or built alongside in the Korean yard, built alongside the Deepsea Bollsta that's currently under contract to Shell. It's again, very, very high spec. It's currently owned by John Friedrichsen's company, Northern Ocean, and under the management of Odfjell Drilling. Okay. So you say Mira and I say Mira, is that what it was? No, it's the other way around. It was the other way around, okay. It's the West Mira. Yeah, I mean, we understand right now that's actually down in the port of Walvis Bay in Namibia, and is going to be heading out to test the Venus 1A. Yes, another rig that I've had personally quite a lot to do with, West Hercules. Again, it was a very high-spec rig for North Atlantic operations. We'll talk about it later, but it's a GVA 7500 design, still owned by Seadrill, but also under the management of Odfjell. But again, a very capable specification. And this one is actually contracted to the Portuguese company Galp, and we understand that that's got at least a 2-well program with optional testing. You mentioned the rig types, and can you just say a little bit more about the rig designs? Well, it's interesting. We've seen it just from the previous slides that there's been a shift from predominantly drill ships to the harsh environment, dynamically positioned semi-submersibles. Again, as I said, designed really for the northern high latitude drilling to deal with the swells, metocean conditions, and probably a little bit better at dealing with strong currents as well than the drill ships. They have generally 8 very powerful thrusters that can remain on station. So there's no anchoring or connection to the seabed apart from the drill string itself. They stay on station except for the most extreme storms. There's 2 dominant designs, and you've seen them both represented here. There's the Moss CS60E design, which covers the Deepsea Bollsta and the Deepsea Mira. And then there's the GVA 7500, which is the West Hercules, and an example is also the Deepsea Stavanger, which has been working in the Brulpadda discovery in South Africa. So as well as the basic design, there's actually 2 different types of drilling systems. That's true. There's 2 predominant providers, and you can choose these things. When you order your rig, you basically choose these from a menu. So it would be, if you go with the NOV package, which is mostly yellow equipment, you get 1 package of automated equipment. And if The alternative is to go with the Aker MH Worth design, which is predominantly red equipment.
So what do you actually mean, when you're saying that the different drilling systems?
It's the type of automation, whether the power is primarily electrical or hydraulic, or there are various subtle differences between these two packages, but you end up with capabilities that are very similar in the end. So it's a different route to get to the same place.
And then in terms of the equipment you got on there, we've got some pictures here. What's going on there?
Well, again, these are things you would choose from a menu when you're specifying the rig, but we can either have knuckle boom cranes or we can go with more conventional cranes. The BOP specification, whether it's 5 ram, 6 ram, and weight and so on. So there's some various variations there. And we can have different types of riser tensioning devices. The photo there is the direct acting tensioners, which are the gigantic hydraulic rams that support and hold the marine riser in tension. Or we can have a more conventional wire rope, and the tensioners are up on the deck rather than down in the moon pool.
So when you say the cranes here are yellow, the BOP's yellow, so you can assign those to NOV, and the red?
Yeah, exactly. So there'll be the drilling system. So there'll be the top drive and the hoisting system and the pipe racking systems and iron roughnecks and all that sort of stuff are going to come from those two companies as yellow or red items.
Oh, cool. I hadn't ever spotted that before. So how much do these rigs cost?
Well, the rig rate, we've had a recent fixture, if you like. We like to say fixture, so we know exactly what the current rate is, and it's very competitive with Norway. So the most recent one is somewhere between 430 and 460,000 US dollars per day for one of these harsh environment DP semi-subs. And the overall cost to the client for each day that the rig is operating, which would be the rig cost plus the additional spread, which would be boats and helicopters and services and so on, it's going to be around 750, 800,000 US for every day that they're operating, whether they do anything useful or not.
So that's nearly $750,000 a day just for the rig.
Rig and the services with boats and things, yeah, for everything just to tick over.
So if we take a look at how much does this all cost? Well, here's a map of Namibia, and you can see all the wells to date until around about 2021 are marked on here. Now, according to NAMCOR in their annual report in 2021, they spoke of 16 wells had been drilled in Namibia over the last 48 years. Now, if you look at the scale bar down there, you can actually assess that the Namibia coast is something like 1,600 kilometers long. So if there are 16 wells in there, that's about one well every 100 kilometers. It is sparsely drilled. Now, we've actually counted up the wells that are offshore here on this map, and we make it 12. We see about 3 wells that are on the coast there. And also not shown on here, we know there's a number of research boreholes up and down the Namibian continental shelf, outboard of that, of which we have 11 in our TROVE database. This is a list here taken from TROVE. You can see that there are 8 wells being drilled on the Kudu Gas discovery, not being developed yet, but of the 12 legacy exploration wells we saw on the last map, and most recently in 2022 and the first quarter of 2023, there have been 5 wells drilled. We're anticipating there might be as many as 10 to 18 wells drilled in the next 18 months. Now, if we actually kind of assess the cost of those, plus all the 2D and 3D seismic that's been shot over the decades, and then add to it any other operations, licensing fees, studies, etc., we've come up with a sort of an estimate, which is back of the envelope, of somewhere in the range of 4 to 9 billion US dollars. Now that compares to the gross domestic product, or GDP, of Namibia, which stood at $12 billion back in 2021. So this is a substantial proportion of Namibia's GDP. We're going to have a look here at NAMCOR. NAMCOR, of course, is the national oil company of Namibia. And, do you know much about what is it they actually do?
Well, they take care of their domestic E&P business. They also own some foreign production, and they are the domestic downstream or retail company that manages the distribution of fuel and so on in Namibia.
So, I mean, they're actually quite small in terms of the number of full-time employees. And in the 2021 annual report, they lost, the group lost 8.5 million US dollars. Now, at this stage in the company's development, that's not a huge sum. But in terms of their involvement, and this map here shows all the licenses that they're currently in Namibia.
Yeah, and they get a free carry of around 10% equity in each of those licenses. The net cost to Namibian individual citizens is zero or negligible at the very least.
Okay. So we kind of put this summary together. I'm not sure that it's entirely correct, but the gross revenue that there's been to date from Namibia, from the oil and gas sector, has been zero. There's been no production, no barrels produced. There hasn't been any profit. So the costs that are probably real in 2023 money is in this range, $4 to $9 billion. But maybe there's a better estimate out there. So what are the next steps? The Kudu Gas Field development, Kudu's been around for a long, long time, and it just really hasn't got to FID. But it looks like it might be moving forward now, and it's BW Energy. It's in about 200 meters water depth, so that's pretty shallow for this area. And this was some news that was recently announced.
BW Energy are buying the 6th generation semi-sub, the Leo, from Aquadrill, and the price has been named at 14 million, which is seems like a very attractive price to me, to be honest. The rig was quite long-term cold stacked in Gran Canaria, I believe, but it's a high-spec, modern drilling systems on board, and it should be very effective in that 200-meter water depth.
And so the plan is to actually use this as possibly as a drilling rig, but in time as a production unit, and actually will pipe the gas back to, I think it's Elizabeth Bay would be the landing point, and from there they'll actually generate electricity from the gas and use that to generate electricity for the grid. We wanted to have a look at what the costs might be going forward, and this is very much a sort of a plucked out the air, an estimate, and we don't know how big these fields are going to turn out to be, how many there's going to be, but we've pulled a number out here of somewhere in the region of 3 to 8 billion US dollars for each oil field. Now, what would a cost like that, what would it kind of get you?
I think that's going to break down. So it's going to be the wells, each well, whether the producers or injectors, are going to be around 100 million US per well. We're going to have an FPSO. It's going to be, depending whether you're repurposing an old one, but it's going to be sort of 2 to 4 billion in that kind of range to buy and commission, install an FPSO. Shuttle tankers will be under OPEX, but it does reduce your margin, of course. Export pipeline is something down the track, probably for gas. It's going to be quite important. Synergies, it's hard to know how that's going to develop, but depends whether the Kudu pipeline has sufficient capacity to tie in additional fields. And there's terminals, refineries. Yes, it's all. I think per unit, it's quite a good estimate.
And of course, if you have to have multiple FPSOs, how much are you kind of adding each time there?
Probably 3 to 4 billion.
And, I feel like Buzios offshore Brazil, I think we're talking about 11 FPSOs there.
Wow.
It's huge. It's amazing. So we looked at this idea of, if a decision was made very, very shortly, that perhaps there could be as little as 2 years to get an early production scheme up and running. And we kind of based that on what Eni has done at Baleine up in Côte d'Ivoire. And if we did have that scenario with some production, we might see that payback, so actually getting the money back, the oil companies might have to wait to 2027. And that's in a very, very aggressive production timetable. This is an analyst estimate, and it's from Rystad Energy, and they've made an assessment. So for TotalEnergies at Venus, they're talking about a phase 1 startup in 2028 and a phase 2 startup, which presumably would be some additional FPSOs perhaps, out in 2033. And again, their assessment for Shell's Graff discovery here would have first oil in 2032. So quite a long time, with a lot of money and investment actually out there for quite a number of years. So Colin, how do we kind of summarize what's actually happening with rigs in Namibia?
We're certainly seeing a substantial shift from the initial predominance of drill ships to the harsh environment DP semi-sub market. It's going to put a lot of pressure on that subset of the rig market, certainly for Northern Europe as well. So it'll be a big change. Also, we need to have further development of the shore-based facilities. An example was the Walvis Bay, which has already been developed to a large extent, but we're going to need a lot more support for developments of this scale. And the next step, I suppose, is following this phase. Now we're into an appraisal drilling phase. It's going to be the commitment, the financial approval and environmental approvals, I guess, for the deep water developments.
Yeah, I mean, and when we look at the sort of the estimates we've put together there, there's been a huge investment already, but there's even bigger investments to come. I mean, billions upon billions of dollars. So we need companies with very, very deep pockets who can actually fund some of these major capital investments. And there is not going to be any profit for many, many years to come, perhaps even for a decade. But it's going to be one to watch. And I think we'll be coming back with follow-ups and updates in our future videos on this channel. So it just remains to thank Colin for your input today.
Thanks, Mike. It's been a pleasure.
Cheers, mate. And Colin will be back in the future to help us out with some of the technical issues associated with drilling. And I'm sure we'll learn lots in future videos. So do subscribe to the channel. Please click the bell and we'll inform you when we're going to be putting out new videos. And look forward to seeing you back on our channel before too long. Safe travels.
Thank you.
Cheers.